All right. Hello and welcome back to Devcom Tutorials. And yeah, we're in the middle of talking about Unity. Doing stuff in Unity. We've started the last time. We've done our first session where we started doing a few things in Unity. And as you can see, just have them here on screen. We started creating a few geometric shapes because, well, that's what we had by then. So we created a cube, a sphere, and some other things that look quite nicely. And we talked about a bit the difference of world space and local space. That's quite important and quite interesting. So if you've missed that, rewind to last time's session and catch up on that. Otherwise, if you already know all of this, well, this maybe isn't for you because this is beginner level for people who maybe have started Unity before to see what's there, what can I click, what can you do. And today we will start writing our very first C# script. Because all these neat little things like the cube and the sphere and all these things that we created last time, we're going to make them move today. And we're going to be talking about how we do this in C# and what other options we have to make things a bit more flexible. And yeah, we already talked a bit about best practice. So what's the best way or the suggested way of doing things. So even if you're just starting out and you have other things to take care of, but to keep to best practices, you first have to see that you get anything working at all and try to understand things. But you've heard it already. So we talk about this so that you have heard it already, so that once you're, well, feeling good enough, like, okay, this is, I know how things are done, I know how to do this, so that when you have enough mind left to actually take care about, okay, how are the best practices, what's the suggested way to do things, that you've at least heard these things before and they're not completely new to you. All right, I also got my throat lubricant here, so should the throat need lubrication, I can do that. And see you on the other side of this neat intro. And let's get started with doing some C#. This might, I might bite my tongue a few times saying C# today. So yeah, well, let's get started with doing some C# in Unity and make things actually move. Cheers. All right, so here we are. This is our Unity. This is our Unity project we created last time. Again, if you've missed this, rewind, watch last time's session to see what we've done. We haven't done much. So if you already know your way around a bit and you know how to create game objects, like, you know, okay, I want another cube somewhere, I can just say, okay, I want a 3D object, I want a cube, bam, and there it is, and it's super huge, it's way larger than what we built, and you can move these things, and if you go like, okay, that's maybe one cube too much, you can also throw this away again. So, making these things move. I already set this in Unity to make actual game logic, because just building a level, building a map, a scene, a world, or whatever you're building, just putting things in there, even if you have super nice 3D models and you put them and you really build the beautiful stuff of all scenes. It's of little use, and yes, you just want to use it to make virtual photographs like screenshots or anything out of it. It's of little use if there's nothing that actually happens inside, if there's nothing that actually does something. So while we have our nice tower of pizza, pizza, now I'm hungry. While we do have our nice tower of pizza here, This thing might be an American pizza because, you know, it's with a thick bottom thingy and stuff. Why do we have this sphere? Oh, we have this sphere left because we wanted to demonstrate the coordinates, you know, local space, world space, because the capsule, this capsule here is at 0, 1, 0 coordinate wise, and this one's at 0, 1, 0 as well. Just this one isn't, but this one is at 0, 1, 0, but yet it's somewhere completely different, like these things. But again, we've covered this. Dadla, hi there. Greetings go out to you. A wonderful evening. I hope the sun's shining at your place, because the sun's shining here, and you're not that far away from me. I think it's about 200 kilometers or something, right? If I remember that correctly. So yeah, nice weather out there. Perfect weather to do some coding stuff. Yeah, I mean, these things, they're sitting there and doing nothing, and a game lives from two things. That stuff in the game does something, and that the player can do something. Because if we start this now, and this down here, this is our game view. So I've started the game, so the game inside Unity is now running, and I'm going to be maximizing this to demonstrate this is my game. But this is kind of a boring game because nothing happens. Inside the game, nothing moves. If I hit buttons on my keyboard, nothing moves. Nothing moves. The only buttons I could hit that actually do something would be Control Alt Delete, but that then would be Windows doing something. And not our game. Oh, the Indie Stolke. Hi. A wonderful evening to everyone who's coming over from the Indie Stolke. So I guess you've done, what have you done? Did you do coding today? Did you do? Yeah, at this time of day you usually do coding, right? If you do the gaming stuff, you do this usually more later or something. Yes, greet you at first or something like that. Hi guys, so nice of you to raid in here, and hope you had a wonderful day. And you did crazy things with rotations in Unreal. That's cool. So you could, like, I don't know, you take the model of the character of the game and you just make her spin and do pirouettes or something. That's basically, yeah, that's the rotation for you. Nice. That's cool. We might do rotations. Yeah, I think we could do rotations today as well. I was planning to get things to move at first, but we could make them move and rotate. That's a good idea. Only that we're on the other side of the world. We're not doing Unreal anymore. We've done this plenty in the past, and now we're sticking to Unity a bit. So yeah, hi there, and again, welcome to everyone who's joined in from. I'm from the indie. Now Rascals isn't the right word. I'm looking for a proper English term for Stolche. Rascals doesn't quite cut it. It's I'll find something. And once I did, I'll let you know. Well, yeah, make yourself comfortable. And see if you got coffee. I think I got. Oh, look at that. I actually got a teeny tiny little remainder of coffee left. So let me kill this one first. Yeah, it's cold, but you know the saying, cold coffee makes you pretty and beautiful and everything. And I could certainly use that. So yeah, you see this very nice tower of geometric shapes. It doesn't do anything. It just sits there. I think this is the most boring game you could build. I mean, it's not even pleasing you aesthetically, and it's not even doing anything. So we just cut it out, and I think we can delete this sphere. This was just to demonstrate this this local space, world space confusion. And just because I like it this way, let's set all this stuff back to 0, 0, 0. So it should be. Oh, and we also need to move this one. Or we could, because this looks kind of neat. I mean, with this thing here, This looks kind of neat. So this is at 0, 2, 0. Oh yeah, this is at 0, 0. This is 0, 1, and this is 0, 2. Okay, I see. I think I understand the math that's going on here. So at least now we got our stuff neat and tidy in the middle. So if we start moving it, there's actually some space where we can actually see it move. So this is, let's say, for now, this is our player thingy. This is what is going to move. So let's see how we actually do things, or how we can, well, how to phrase it without using the term code. How to tell things in your scene, in your game, to actually do something. And in Unity uses something that's called C#. So this, yeah, that's it. It's a programming language. Some of you might know it, some of you don't. So if there's any questions, just shoot, put them in the chat. I won't be going too much into depth of object orientation in general. So you should already know what a class is, what a method is, what a property is, or in the special case of C#, there's even properties and fields, which are a bit different and confusing if you're coming from other languages. But that's things that you should already know. If you don't know them, then just let me know, and I'll see that we get it somewhere in between, that we maybe do some coding basics to get these things explained. So that could be a VR game, he thinks. Could try to keep the objects balanced by using motion control. Yeah, but VR might go a tiny bit beyond the scope of this tutorial. We could do a tutorial. Let's just check my cables that I don't kill them while rolling around with my chair. If there's enough interest, we could do a tutorial on VR. But for now, we just stick to the more basic things and just get this moving at all. The first thing is this is okay. This is our roadmap for hopefully today. Let's see if we manage to do all these things today, and if we don't, we'll just continue next week. So at first, we want to make this thing move at all. So it just moves by itself in some nice direction. So everything's cool and already moving. The second step will be to make this controllable by the player. So you can use keyboard inputs to move it sideways, forward, backward. Maybe we even do up and down. I don't know. Let's see how that works out. So, since we want things neat and tidy, in the assets folder, I will create another subfolder, which I call scripts, because that's usually where in Unity you just put your C# scripts. You could, of course, name this anything you want, but try to keep it organized. This will make your life easier down the road. So for now, I'll just create the scripts folder. Oh, we won't be ending up with too many scripts. So, and then in the create menu, you know, last time we clicked up here in this area, or you can even click here. And we also have, we have create empty, and we have create 3D object. We have 2D object. This is all the things we could create here. Now I do a right click on my scripts folder. And I'm also going to create submenu here that gives me quite a lot more options of things that I could do. And one thing I could create, well, look at that, a C# script. So let's do that. And now we need to give this script a name. And usually you name your script so you know what's inside. So the name of the script should quite short, like just one word, maybe two, describe what is the functionality that is being put into this script. So we want to do something that moves our little thing that we got there on screen. So we will call this movement. Mover, yeah. We could call this mover, or movement. You can do whatever you want. Well, at least as it describes to some degree what's going on. And another good practice is yeah, not to call it copy of new script in brackets 3. That's the perfect. This is the perfect name not to give your scripts. And another good practice is to use a suffix, because now, okay, we know this is gonna be something to do with movement, and some terms you might hear quite often or see is either a controller or a component. I think in this case it'd be safe to call it one of both, all right? Because we could say this, okay, this is our movement controller, because this is the script that controls the movement of something. We could also call this movement component, because we'll be putting this as a component on one of our game objects. So I will go with movement component, because I won't be getting too much into depth with this, but controllers are usually something, well, a bit more. It's a more special case of a component, or it's something that actually manages from one script multiple things in a level or something. So if I get my my spelling right, component. Well, that looks good. So let's call this a movement component, because once we've done the script, you will see we will be putting this as a component onto our game object. So before we just take a very brief look at where are components and what are components, let's just hit the return key. So this is our name. This is movement component, and you can already see that Unity created a rough skeleton of code for us. So when you create your scripts in Unity using the create C# script option, Unity creates an empty script for you with a basic setup. So this one will now just work. It won't do anything because there's no actual code in there, but it could already drag this onto a game object as a component, and it would work perfectly fine. And there's one or two things that are quite special. So this does actually work, which we'll be talking about once we have the script open in our programming editor. Let's have a brief look at components. If I click now, first let's create an empty game object. So here's a simple empty game object. This is simply, well, an object that has nothing. It just exists. It's just there. And you see in the inspector, we have our transform. This is the position. This is what we toyed around with quite a lot last time. You see, if I drag this around, if I move this, these numbers change. So every game object, it always has a transform. We talked about this. Again, we talked about this last time. The transform is where is the object, how it's rotated, what's the size, what's the scale in relation to its original size and stuff like that. So every game object that is sitting somewhere in your scene has such a transform, because it needs to exist somewhere in your scene, and to exist it needs to know where and how, and this is basically the transform. So this always exists. And that's it. There's nothing more. It's complete emptiness down here. But we got a button add component. This doesn't do much for us yet because we don't really have a component we want to add to this game object. But if we take a look at the cube, this one down here that we added last time, we can see under the transform there's quite something happening already. There's a few things, like we have this cube mesh filter, we have this mesh renderer, we have this box collider. And these are all things that are required to actually show this 3D model, because even since this is a very simple cube, it's an actual 3D model. Something that we call a mesh or something. So these things are necessary, they are required, and they are components. These things they are components. So everything that you can slap onto your game object is a component. And there's components like, I gotta admit, I don't know what the mesh filter is. But the mesh renderer, the name is the deal. The mesh renderer, it knows the 3D model that is supposed to be displayed. And then it takes care about actually rendering this 3D model with all its textures and everything it has onto your screen in the scene. And then there's a box collider, which is when we do collision. We will be doing this a bit later on down the road. Not today, not next week, but I don't know, maybe in 3 weeks or so, we'll be ending up doing collisions. So that is when the colliders come into play. So we don't bother too much with what these components do that we have on here. We just know these things, they are components. They are kind of put onto the game object. They're attached to the game object, and they live as part of the game object. So the game object, if you phrase it the other way around, the game object has or contains or owns, depending what word you like most, it all works, has these components. So these components belong to this game object, and they can access it, they can influence it, they can do stuff. So back to our empty game object, and we said, okay, our movement component, basically by default, every script that you create using this create C# script option is by default something you could call a component, because we haven't done anything with this yet. We just created it, and it's just sitting there, and it's basically completely empty. But we can already drag this, and this is how you, at least for your own components or for your own scripts, this is how you attach your own scripts, your own components onto a game object. You have the game object somewhere here, and then you just drag your script. You just drag your script either directly onto the game object here in the hierarchy view. That is one option. And the second option is if you select your game object and you have the inspector view with all the components shown that it currently has, which in this case is none, you can also drag your component directly here into this inspector view. And once you let go from the mouse, there it is. You can see it appeared movement component. It says that's a script. Both is right. Movement component is the name we gave it. And you can see Unity formats this a bit more human readable. It puts a space in between the separate words, because let me see if I can magnify this quickly. You see, I call this movement component in what's called Camel Case, which means the first character, it starts with an uppercase character, and every single word, because the whole name is one huge mess of a word. And even if the name consists of multiple words, they are just spelled out as one long word. But each actual separate word, like component is a word for itself. So the component then has a capital C. So it's two words put into one, but every original single word starts with an uppercase letter. So movement component with upper M here and the upper C there. That is called Camel Case, because of the hums of the camel and stuff. I don't know why people call it. Somebody, somewhen decided we call it that way because for some reason it reminds him of how camels works. So yeah, so we got stuck with that name. And Unity sees this, and it knows, okay, you called it like this, but since there's an uppercase character, this is basically a different word. So it named it a bit more human readable. I put a space in between there, so us puny humans can understand this a bit more. This is the only halfway readable way to do if underscore is not allowed. Technically, you could put an underscore there. You could create a script and put an underscore there, but it's not best practice, and it's basically violating the coding guide, because I've said this when we've done Unreal before, especially when we talked about Unreal best practices. In a perfect world, no matter how many people are working on the project, the code looks like it's been written by one single person. So we have to stick to a common coding style, and this is actually the things we're going to be doing here. This is actually C# standardization. This is the standard best practice C# coding style. So this isn't even something that Unity came up with. This is something that the developer community around the programming language, or the guys who actually invented and maintained the programming language, came up with. Like, this is the best way to do it. If we all stick to this, then everyone will have not that much of a problem reading everybody else's code. And once we're in the IDE, depending on which IDE, which programming editor you use, your IDE can already tell you when stuff is not right. So the IDE that I use, which is Rider, which was not renamed to Twix in Germany. there's still a lot of places where Rider is still called Rider. And even in Germany, this one's called Rider and not Twix. To get that joke out of the way. Check, done that. It will tell you if you name your things that does not fit to the convention. It will tell you. It will notify you, like, hey, this is not exactly perfectly like the convention, like the best practices say. So you can either leave it, which is a bad idea, or you can actually see to correct this and name things properly. Yeah, and the camel casing and no underscores. This is the convention for script names. Also, I think someone told me that they changed this. This is not totally needed anymore, but it's still a very good idea to do this, and you should absolutely do this. The name of the file and the name of your class in the file should be absolutely identical. So, and we're going to be looking at this by just opening up our first code file in our IDE. And you can basically, with Unity, you can use any IDE you want. By default, Unity comes with Visual Studio, but a lot of people like to use Visual Studio Code as an editor. I personally, I'm a huge fan of the JetBrains IDEs, which in this case is Rider, which has quite a lot special integration for Unity. So Rider knows how to deal and how to handle with Unity code, because it knows about all the special things that the engine offers you or needs or stuff like that. But you can use any editor you want, and you can actually change this if in the menu up here you go to Edit and then do Preferences. And you can also do this because sometimes after a fresh Unity install, even Visual Studio does not properly launch. It might open your single files that you want to open, but it doesn't open your whole project, which is a huge difference, because C# files on their own can't survive, because they need all this stuff around them, because we will be using quite a lot of things that that don't exist, that can't be found if you're just opening this as a loose file. So if you double click on this and you want to use Visual Studio because you don't want any other IDE, and Visual Studio comes with, Unity installs Visual Studio by default if you do the default fresh Unity install. So Visual Studio is just there for you. But if it doesn't work, you can also do this. So you go in the edit menu to Preferences, and then you have these external tools. And let me see if I can magnify this again. So we have the Preferences, and there's quite a lot of things in here. And there's this External Tools category. And we're going to be hitting the External Tools category. And then up here, the very first thing, External Script Editor. And sometimes this is by Open by File extension by default, and this does not work. It works for just opening single loose files, but you won't be able to make full use of the full extent of the features that your IDE offers you to support you while writing your code. So it's always a good idea to check by external tools, the external script editor, if this is set to open by file extension, because this does not work. If this option is selected, you will have problems properly editing your code. So it should be set to Visual Studio Community, because this is what Unity brings and installs with it when you just do the first fresh install. So if you don't have any other IDE and you don't want to use anything else, you can just see that it's set to Visual Studio Community. If you have Visual Studio Code, this should be listed here, and you can just select Visual Studio Code. You can always also just browse to your favorite editor and use, like, I don't know, some people like to use Notepad++ for coding. So you could even do that. Just select the Notepad++ executable here, and then everything's fine. Yeah, me personally, I like my JetBrains, my IntelliJ originating IDEs. So for me, this is Rider. This is perfectly fine. So now Unity knows that whenever I want to edit a C# file, it's supposed to open Rider for me and then tell Rider to open this project, because this is the reason why this open by file extension doesn't work, because your IDE needs to open the whole code project and not only a single file. So yeah, but this is where you can actually set whichever editor you like or IDE you like to use for your coding endeavors. So let's get back into the file. Let's actually find it, because by default this I'm just here on the file, there's nothing. So I have this little neat crosshair button here that in this tree view of the project immediately finds my file and selects it for me. And this is the base template. This is, and let me see, we can make this a bit larger if we go to, should have done this from the beginning, enter presentation mode, and there we are. Let me see that I get my side panes back that I like using. Oh yeah, like this one, and also this one. Yeah, so this is perfect. This is how I like it. So now you should be able to read this way more better in the stream. So this is the basic template. This is the skeleton code that Unity creates for us when we just create a new empty C# script. And there's a few things to take note. If you've never worked with Unity, with C# in Unity, there's a few very important things. The very first thing is this colon mono behavior. This is a C# construct and means our class is movement component, because that's how we called it. This is our class. This is our code and everything. But this class extends the mono behavior. This means C#, when it sees our class, our script, with our code, it knows, okay, you want to call this movement component, fine. But it gives us everything that is included in a class called mono behavior. Every functionality that this class has built into it, we also have in our class. I won't be going too much into depth of this. This is inheritance. This is extending another class. This would be object orientation basics. If there is interest, if you do want a session where we talk in depth about basics of object-oriented programming, then just let me know and we can do this. So this basically means that there is a mono behavior class, and this class is part of Unity. This class is part of the engine. You can see here it's coming from the Unity engine namespace. So this is part of the engine. And this contains quite a lot of code already. There's a lot of functionality that's already put into this. And also this is everything that's needed for our class actually be able to live as a component on a game object. Let me demonstrate this. If we go to our empty game object and I remove this component. Remember, we added this when I just dragged my component into here to add it, and now I just removed it. It's like I never added it at all. So let's go back into our code, and for now, let's remove this mono behavior. Let's save this. Unity will automatically compile all your code. So whenever you save, or at least when you go back into the engine, Unity will start compiling all your changes. Is there something like a constructor? You can, yes. First of all, hi there. Wonderful evening to you. Given you this at least a similar time zone to me. Yes, this is basically a normal class. The only special thing about this class is that usually it inherits from the mono behavior. You can use your normal constructor, absolutely no problem. This is simple, normal C#. There's nothing out of the ordinary except for all the functionality the engine offers us and gives us. But you could totally do a constructor if you need this. Most of the time, you don't need a constructor because of the start function. But we'll be talking about this in a minute. Because there's these two functions that by default Unity puts in there. There's a third one that's quite important. We're going to be talking about this in a second. But for now, see, I removed the inheritance of mono component. And if I now try to drag my class onto my object, it doesn't work. Didn't want to get ahead of. No, it's okay. Asking questions is perfectly fine. So yeah, this is why we're here. This is why we're doing this as a live stream and not a pre-recorded video on YouTube. Every question is welcome. So, and now I try to drag my script onto here, and Unity tells me, okay, sorry, I can't add this script because your script has to inherit from mono behavior, or otherwise I just can't add it as a component. And the reason because it can't do it is because all of the functionality that is required for a class to work as a component on a game object, and all this code, we don't have to write this ourselves. We don't have to copy paste this into our code. It's all contained in this mono behavior class. And this is why we need to inherit from this mono behavior. Also, these things, they don't work if we don't do this, because one of the many things that is contained in the mono behavior is the handling of these functions. So the comments above here, they kind of already tell us what's going on. So we have this start function here, and this is basically called, well, it says at the first frame. So, but if at the first frame when the game is running. So while we're here in the editor, the game is not running, so start is not called. However, the constructor is called. And this is a very important difference, and you have to be this is also a reason why you have to be quite careful when using actual class constructors, because they are called when your class is instantiated, and your class is instantiated when you drag your class as a component onto an object. Okay, we didn't save and compile, so this is why we can't do this. Let's save this quickly, and when Unity is done compiling, we should be able to add it again. Yes. So this is already instantiated now. So if I would have had a class constructor, it would have already executed. The start function, this one, however, this one is not called yet. This one hasn't executed yet because it's executed on the first frame of the game when we actually start the game. So when I hit the play button up here and the first frame of our actual game starts, then this function is called. And we can just demonstrate this, but just put a little debug log in here that tells us this is the start method. So save this, let Unity compile, and let me remove this again just for demonstration purposes. So I remove this, and if I now drag my component, my class back onto the object, nothing happens. See down here, this is the console where all these log messages will appear. So nothing happened. But when I now start the game, on the first frame of the game, when the game started, you can see there it is. Here's our log messages, our log message that tells us this is the start method. Because it's called once and only once. Let's get rid of the magnification again. Okay. So this is called once and only once on the first frame when the actual game runs, which is this distinction between when the game runs and when not. This is only important in the editor, because if you've built this as a standalone executable with your game.exe and you run it, then it runs from the very beginning. So whenever an object is instantiated, the game is running, because without the game running, no code could ever instantiate your objects. So this is only important while you're in the editor. And sometimes, and we've had this in the past quite a few times, sometimes, and this is really weird sometimes, things work in the editor. You try out your game in the editor and everything works perfectly fine. And then you pack it into a standalone package, your game.exe, that you can just run on any Windows. And it doesn't work. And there's a few reasons why this might be, and this might be one. So yeah, this is in case of the constructors, this is to take to be careful about. So yeah, our start function. I want to go here again. Is there some kind of culling? Meaning, is the start called even if the object is not in the current view? Yes, it's always called. So no, the culling only. The culling is for rendering. So you cull objects if they are not in view, so the graphics card doesn't have to bother about them, to speed up performance a bit. But when the object exists in the scene, start is called. This has nothing to do with visibility. If, for example, you do want your start only, or the update for that matter, you only want to execute this when your object is visible, you have to take care about this yourself. In the start function, I'd say it's quite a bad idea, because the start function is only called in the first frame, so when the game starts, and never again. So if you don't execute your piece of code when the object is not in view in the start method, and then sometime later the object becomes visible, start will not get called. So this has nothing to do with visibility or anything. If the object exists in the scene and it's enabled, we'll be talking about this in a minute, because there's a similar function to start with a very important difference, because you can enable and disable objects. We'll be talking about this in a minute. If the object exists in the scene and it's enabled, then start is executed always, no matter where it is. If it's, and you know what, I'm gonna be shutting up this light. I have no idea why it's getting so many joins. I don't know, some network crap again. So Yeah, we should be done with that lightbot spam. Nobody's changing the light in the moment anyways. It would have been to change the light in the background, but, well, yeah, we just don't do this today. Still need to throw the spamming out of the bot. Lakeside, hi there. A wonderful evening to you. Nice to see you. Hi. I hope you had a wonderful day and you're already preparing for the weekend, because everything that's between us and the weekend is one more day, Friday. And Friday is basically almost weekend, so that doesn't really count. So we're basically almost in the weekend. Is that nice? I like that. So yeah, start is called at the first frame of the game when the game starts. And you can do initialization stuff. Jesus Christ. My speech processor today, it's a bit laggy. So you can initialize your stuff if you need it when this starts. And we're actually going to be doing an example of this. Yeah, if you got enough time, we might do an example about this. So if you have any initialization that you want to do, stuff you'd usually put in the constructor. So only use the constructor if absolutely necessary. Usually put all this stuff into the start method. This is usually a quite good place where all your basic initialization of your class or whatever you need to do there is taking place. With a lot of projects, it's difficult to do at 4 p.m. Yeah, it's a bit early. 4 p.m. is a bit early. But I don't know. Let's see how season 3 will turn out, given we'll be renewed for a 3rd season. I feel like I'm on TV. Hi, Mom, I'm on TV. And even if it's just Twitch TV. And then there's this update method. And also, the comment up here already tells us all the magic. This is called every frame. Every single frame the game renders your screen, our update function is called. So if your game runs at 60 FPS, this is called 60 times per second. With each new frame, the game calculates and renders and generates. This update function is called. So if we want to do something between frames, like move an object maybe, this is where we do it. This is where we put our code that we want to constantly run every frame, because we need to do calculations that are important. Or if in this case we want to move our object. In the update function is the place of choice to put this, because I mean, where else would you put it? Because you need your movement to be constantly called, because you can't do a loop. You can't do a loop that moves it by a pixel and then waits for a bit and then moves it again, because for as long as you don't exit your loop, the game's frozen. Because this is already getting a bit too far, but for those of you who says this something, because it's all running in one thread. So even though it really looks like there's a lot of things happening at once, nothing is happening really in parallel. Everything's happening one thing at a time. They are just quite cleverly scheduled. So yeah, now you do a bit of work, now you do a bit of work. And for as long as these methods don't return, nothing else matters, you could say, because nothing else can be called and do its job. So you need something that is called every time so you can continue your work. So you have to put, and we're going to be seeing this when we do the actual movement code, that you can't just do one loop that moves our object. We have to do our stuff in a way that it always does only just a tiny little bit, and then it can completely exit, it's completely done, and then when it's called again, it continues on its original purpose and intent. So this is called at the very start, at the first frame of the game, and update is called each and every frame. Now there's one more method that is quite important, and this is called awake. And basically, awake does the same thing as start. It's called once when your object, your component is instantiated and it becomes alive. So this is the awake method. But it's called before start. So the order in there these things are executed is at first the awake method is called. Then eventually the start method is called. And this is all in the first frame. This is all in the first frame. Awake is called, start is called. And then every frame, including the first, your update method is called. The difference between awake and start, and depending on what you're doing, this is a huge and important difference, is you can disable game objects. If we go back into Unity and we take a look at our cube, because with our empty game object here, and you know what, I'm going to be removing this empty game object for now. You see this little check mark in front of the name, and let's just not call this cube. Let's call this our main cube player object, whatever. So you can also see that in the hierarchy view, the name of this object now changed, because the name that's displayed here is basically this name, and this is how you are. You can also just click on it and then click on it again, but not double click. Just wait a bit and then click again, and you can also edit the name. So we can like here remove this and say this and call this main player cube. So, and if we now move over here, you can see the name changed here as well. So these are two ways you can use to rename your object to something sensible, because keeping them at cube, sphere, chair, player object, sometimes you want more clearer names so you actually know what this is. So yeah, either you can rename it directly in the hierarchy, or you can, if you have the object selected, you can rename it up here. Same thing, same name. And now you notice this check mark up here. This check mark is used to enable or disable a game object. By default, clean code is so important. Absolutely. Yes, this can't be stressed enough. And this also goes for the hierarchy of the level objects. But yes, clean code. This is why I told you how these things should be named, and it goes down to what I said before. In an ideal world, no matter how many people work on this project, the code looks like it's done by one single person, because everyone does it the same way. Everyone adheres to the same conventions, and clean code is readable code. And fortunately, modern IDEs help and support us. Just a quick example, like when I completely mess up the formatting here, like I don't know, I put this like so, and the indentation is completely off, and also this is totally not where it belongs. This, you can already see, even with this basically no code at all, this starts to become quite unreadable. And most IDEs, at least the IntelliJ ones, the one writer that I use, have a neat function to take care about the formatting. So I can now just go into my code menu and tell it, if I find reformat code, I can just say, okay, you know what, dear IDE, I completely did not care about how I format my code, because that's your job. Please take care about the format. Reformat my code, and okay, I kind of missed the comment there, but you see, and all of a sudden everything's fine again. The curly brackets are on separate lines, and everything's indented the right way. So yeah, Form is one thing. Yes, of course. It's the form is only one thing. There's quite more to it. You're absolutely right. Imagine how many objects you have in games like Far Cry. Yeah, there's a lot. There's a lot. Naming is so important. Speaking method names. Yes, absolutely. And this is another thing where your IDE can help you. And we'll be seeing this when we start putting properties and fields in here, because that's something we'll definitely be doing today. So, but yeah, absolutely. This can't be said too many times. This can't be stressed enough. Clean code, formatting, naming, lubricating your throat, and all of these things. Super important, because you're usually not working alone on this. I mean, if this is a side project of you and you're just doing this for fun and nobody else will ever see your code, even then, it's a good idea to have clean code. Because imagine a month later, a year later, 5 years later, you still want to be able to read and understand your own code. And trust me, it happens more often than you might think, that a month later you look at your own code and you're like, what the hell have I done there? So, and especially if you're working on larger projects, whereas multiple people working on one project, it's imperative. It's really a death sentence not to have clean code, because your coworkers, they have to be able to read and understand your code, or otherwise the whole project is deemed to fail. And if your project fails, you can't sell it. If you can't sell it, you don't make any money. And if your company doesn't make any money, then, well, you gotta find a new company to work for. And writing applications and stuff is not fun. I think we can all agree on that. 1 hour, yeah, or even 1 hour later. Sometimes you write something and even 1 hour later you're like, I should rethink this. Yep, absolutely. So, the difference between awake and start is we were talking. Why did I go back into the? Oh yeah, because of the formatting. Okay. One whiskey later. That's a nice timing method. So, how late is it? Well, it's about 2 whiskeys after the last line of code. That's nice. I like that. So yeah, we can disable a game object. And if I do this, if I remove the check mark, you can see everything vanishes. Everything here in this view vanishes. It still exists in the hierarchy, but it behaves like it's not there. So if you disable a game object, it will not be rendered, which is because of all the initialization functions of the mesh renderer and everything. They are not called, or, well, yeah, it's a bit more complicated, but this is the easy way to say it. So everything's turned off. Let me clear the lockdown there, because we're going to be taking a look at this again in a second. So if you disable an object, it's basically like the object does not exist. But it does. It's there. It's just hidden away, and it's keeping quiet, like, well, it's not there. And this is the difference between the awake and the start function. Both of them are called on the very first frame of the game. However, the start function is only called when the object is enabled. The awake function is called always, no matter if the object is enabled or disabled, and start is only called when it's enabled. So since a picture says more than 1,000 words, see, we have our awake function with the log entry. This is our awake function. And we got the start method. The start method. Let's keep correct terminology here. And we got the start method, that tells us this is the start method. So let's save this in case we haven't, and let's go back into the engine. And while the engine compiles, how does a bunch of disabled game object in the scene affect the performance? Not that much, actually. Not that much, because, right? Oh, this is actually quite a good question, because this brings me to something I forgot to mention. Update. Our method that's called every frame is also only called when the game object is enabled. When the game object is not enabled, start will not execute, but update won't execute as well. So update will also not be called when the game object is not enabled. So actually you can use this to save performance, to better your performance, because if you have an object that does something in the update method that is quite intensive, it needs to do a lot of calculations or whatever, and you don't need this object to do these things at the moment for whatever reason, you can disable it, because you can set this enable or disable programmatically. You can access, where is it? There. You can access this enabled state from code, and you can change this at runtime. While your game runs, you can enable or disable objects from your code like you need, like you want. So you can disable an object, and its update function will also not be called anymore. But the disabled game objects are still cached, right? Yes, they still exist. They just behave like they don't exist anymore, but they still do exist. They are still there. They are just, well, hidden away, and they don't do anything. Most of their functionality is halted, paused, stopped, whatever you want to call it. But everything else, in case there's a cache or something, still applies, because they still do exist. They just pretend not to, if that makes sense. But yeah, everything else besides that, like how the engine handles and manages internally the game object, still completely applies, because they do exist. They are there. Yeah. Okay. If that answered the question, that's cool. And now let's run the game. We have the awake function that tells us, yay, I'm awake. We got the start function that tells us, yay, it's start. We're not put any debug log yet into the update method, because this would completely spam our log to death, because it would basically put whatever we put there into the log 60 times per second. So we don't need this. So we got a debug output in the awake function, we got a debug output in the start function, and the object is disabled. So let's start the game. And once it started, this always takes a while. No, it's already started. Interesting. We don't even... Oh, because, yeah, this... okay, my bad. This is what you might call a layer 8 problem. Nothing happens because I have not put our movement component onto the main player cube yet. So let me do this. Let me drag this up here where we can find it easily. So now we got our movement component actually on our object. So let me run this again. And we should see the awake debug log. That we don't. That's interesting. Okay. Okay, this is interesting. Even the awake function wasn't called. Totally not what I expected. Totally not what I've read in the docs the last time I checked. But for some reason, it didn't even call the awake function, which is kind of weird, because I'm actually using this in actual projects where there's game objects that start disabled, but they still do their initialization stuff using the awake function. This is interesting. I will investigate this, and tell you the result of my investigation next week. Because this is totally not what I was expecting. But you see, once we enable the object, both tell us they execute it. The awake label is overridden or something. It's just like the start function. It does override. It does override the default awake of the mono behavior. But start and update do this as well. So this should have worked. I will investigate this. I will take a look why this is the way it behaves, and I will tell you the result of my investigations next week. Because as said, I'm actually using this in actual projects, so the objects can still do their initialization stuff. Okay, yeah, but this should have been the difference between awake and start. So let's just go back to having a start function and at least demonstrate this once the engine is done compiling. So game object is disabled. I run the game, nothing happens. I enable the object, and because it hasn't been called yet, start will be called. Or if the game object is enabled from the get-go once I run the game. And there it is. The start is automatically being called. All right, so let's get to what I wanted originally to do with you. Before talking too much about starts and updates and stuff, let's actually put something into the update method. And because I'm a fan of like we just had it, clean code, and I think this helps having clean code. I like to have every single bit of work that my code does in an own little method that just does this little piece of work and nothing else, and then I just call all those methods I have. So let's create a separate method. And let's call this move, because that's what we're going to be doing. Doesn't mean we are ghosting the object. Well, yeah, you could actually say that. I mean, if you disable it, you see it gets a little bit ghosty. It's shimmering, just an echo of itself. Yeah, well, yeah, maybe. So let's create a move method. And again, I won't be getting too much into the depth how object orientation works, but if you've never seen this, there's three things we have here. We have the private, which is not a military rank like Private Ryan, even though I find it quite funny if you have a private property up here and you call it Ryan. This is stuff that makes me laugh, yeah. This is the visibility. And this basically means that this method is only visible and accessible within this class and from nowhere else. So if there's other classes that instantiate our class and use our class, they will not see this method. This is private. This is ours. Nobody else has access to this. And the second term is the type of what this method returns, because sometimes you have methods that actually return you a result of what they did. A very simple example would be if you have a method that's called add. Okay, because I did not put the type in there, the IDE is a bit confused. Because I'm going to be putting this there in a second. Let's say we have a method we call add, and it takes a number A and it takes a number B, and it adds those two numbers together, like number C, which is also an integer, is A plus B. And it then wants to tell us the result of what C is, because this is an important operation that you need quite often in your project. So this is why you made a separate method. And our method now wants to let us know about the result. So you can use the return statement, which means, okay, this thing is done. We're returning to whoever called us, and we're telling it the value of C. And the value of C is, in this case, an integer. So this is why here we're going to be putting int for integer. So the first thing is the visibility. The other way would public. Public would mean everyone from the outside can see and call this method. There's another thing that's called protected, but again, I won't be going into too much depth of how OOP works. Again, I know I've said this like 10 times already tonight, so this might be the last time, might not. If there's a need for this, we can do this. We can do like an introduction object-oriented programming with pleasure. If there's need for it, if you guys want this, if you have interest in this, just let me know, and we're going to be doing this. So yeah, just know there's also something that's called protected, which sits kind of in between, to do with inheritance, because this is beyond the scope of what we're trying to do now. So the first thing is the visibility. How visible is this thing? The second thing is the type of what kind of value is this method giving us back when we call it. In this case, it's the result of this simple addition, so it's an integer. And the third is actually the name of our method. How are we going to be? How do we call it? And now there's situations where you're not giving back anything. You're like, okay, my method does something, but it's not giving you any return value because there is no return value. There is whatever we did, the work we did, but nothing want to return, and then it's just void. Void means this method does not give you anything back. You just call it and be done. You're not getting any values back as a result from what this did. So since we are inheriting from mono behavior, and this works very neatly as a component on our game object, we have access to quite a lot of things that the engine just provides us with. And remember when I told you every object has a transform, this thing up here. Even an empty game object with nothing on it, no component, nothing. It's completely empty, completely blank. It's even more empty, like an empty sheet of paper. It's so empty that you don't even see your empty sheet of paper. So that's how empty it is. But still, it does have a transform because it has to be somewhere. It has to have an orientation, i.e. rotation. And it has to have a scale. So the transform's always there, and we can just access this with the word transform. Because transform is a property of our class, because we inherited from mono behavior. We do have a property called transform that we can just access. And transform has quite a lot of things. It has our position, it's where we are. It has our rotation, it's how we're oriented, like in whatever way. And somewhere it even has the scale. Somewhere here there's a scale hidden. Maybe I just scrolled through it, but it's there. It's somewhere. I just failed to find it right now. Local scale. Yeah, okay, because it's called local scale. Yeah, I can see that. All right. There's quite a lot more stuff. But we don't have to bother about this now. For now, we want to use the position. Oh, well, these right, left, forward, these are just helper things. If you're super interested, if you want to know what these do, feel free to check the documentation. But for now, we don't bother about this. We want position, because we want to move our object, and to move our object we have to change the position. So we just want to access the position value. And as always, it spawns with weird coordinates. Yeah, this is something I might never understand. If you just create empty, why doesn't it just spawn at 0, 0, 0? Why? It's like random. It's like the engine is using random values and throwing a dice like, let's see where we place this for now. Yep. Position and local position. One is relative to the parent, I guess. Yes, this is something we've talked quite a lot about the last time. The very important difference between local space and world space. And this is why I had this little other sphere here. Because let's just, as a quick reminder, recreate this. I put a sphere. We just make this a bit smaller so it fits to the rest. 0.1, 0.5 was it? I don't know. Maybe it was 0.5 or something. So I'll be putting this at x0, y1, and z or z, depending if you're a sensible person or American speaking. At 0. And where is it? Oh, it's it's right there. Okay, this was why okay, let's move the cube a little to the side. Let's move this to 2 for now. So, and you can see this sphere has a coordinate of 0, 1, 0. And if I select this sphere now, which is clearly someplace else, it also has the coordinates 0, 1, 0. Because this is a local space. This is exactly like you just said. This is relative to its parent. And this is also the reason why when I move around the cube, why everything else, why the sphere and the capsule, why they move with it. Because those coordinates are usually the local space coordinates, which are relative to its parent. Exactly. Yes. Again, if this didn't make sense to you, if you want to know about a bit more details about this, rewind back to last time's session where we talked quite a bit about this. So, for now, we just want the normal position, which, if I remember correctly, should be the local. This should be the local. Let me see if we got something like world coordinates or something. World to local. Well, this is a matrix. This is getting quite weird quite fast. There is a way to get the world location. But for now, we just care about the normal position, which is relative to its parent, which is perfectly fine. We're also going to be trying this out because we're going to be putting this component on 2 objects once this works. We're going to be putting this on the cube, and just for the fun of it, we're going to be putting this on the sphere. And maybe even on the capsule. Who knows? Let's see how crazy we go. So, we got the transform.position, which is a vector 3. And a vector 3 is exactly this. A vector 3 is just a value with a separate x, y, and z value. So we do have the transform position, and because we are neat and tidy and we like clean code, we create a local variable that we call vector, not called, of the type vector 3, because that's the type. Not sure, can we see, wait, if I got the auto completion, yeah, if I got, there's the difference. This might actually be the world location, and this is the local position of the transform relative to the parent transform. So this might actually, yeah, world space. I mean, there it is. See, you just need to read the tooltips on the auto completion. The position of the transform that we're going to be accessing from code is actually the world space location of it. And if we do we would not I mean, we can debug log this out. Let's you know what? Let's do this. Let's maybe not do this in something we're going to be calling from the update. Let's call this from the start method. Let's do a debug log. Let's keep this clean. World position. And this is, I mean, this is just a debug log. I'm doing this a bit dirty now because we're going to be removing this anyways again. So this is transform position X. And then we're going to be having Y and Z. And it's not commas, it's actually plus thingies. Oh, it's starting to rain. Well, it's getting cloudy here. It's getting cloudy. Let's hope it doesn't rain because I don't like rain. I mean, yeah, I know rain is quite important for the world, but I don't like rain. I like it sunny and dry and warm. That's how I like it. So we got our world position, which is position X, Y, Z, and then we do the very same thing, which is our local position. And this is, of course, local position X, Y, Z. And let's comment this out for a second because we want to try. This was the wrong shortcut. What's the shortcut for line-wise block commentary? Comment with line comment. Oh, Control-Alt/. Okay. It was that one. See? Thanks for the menus, because I just can't remember all these I don't know. For some reason, I always fail at remembering these shortcuts. So let's save this, and while Unity is compiling, I'm going to be lubricating my throat a bit. Yeah, lubrication successful. So I don't need to cough into the mic. That might explode your headphones. So let's run this. And this is quite boring, actually. Yes, this is quite boring because it's all 0, 0, 0. Because we should try this. Let's try this at the sphere. And again, let's move this a bit to the side again, so the values get a bit more interesting. And for now, I'll be removing this from here again so we don't get confused with our debug logs. And let me put our little component onto the sphere. So now I removed the component from the cube and I put the component on the sphere. So now those values should be totally different. Oh, and by the way, I did this in play mode, which nullifies everything once I leave play mode. So let me do this again quite quickly. Because this is the thing, everything you do while you're in play mode is undone when you exit play mode, which is quite nice because you can try around and do things and see the results without actually destroying your actual setup. Does Unity have a get component call? Does Unity... Oh, you mean if it does a get component call if I use the transform? No. This property is the property is properly filled. I don't think it does a... Well, I haven't looked at the actual Unity code, but we can do this. I mean, let's take a look. Yes, I know that. Not just get transform. Well, I haven't looked at the actual Unity code, but I don't think it really does the get component because it kind of knows it's part of our object. Yeah, I don't think so. It actually does. I mean, it actually does do a get transform. Whatever that does. Yeah, so the honest answer would be I don't know, because I haven't looked at the Unity source code, but an educated guess would be no. And even if it just does this, I think it just does this once per frame. It just does this once per frame, if it even does it, because the mono behavior takes care of everything and just it fills us these values, so we just have them ready to be used. I don't think it really actually does any calls while accessing it, because it needs to know these values anyways, and they are basically just referenced from the object. It should cache in mono. Yeah, and even if it does, it will properly cache it. But this is engine code. I mean, it's interesting. I can completely understand the question, because I like to understand and to know how things work under the hood. But yeah, I haven't actually looked at this yet. So we removed the component from here and we added it to there. Let's run this. Grab the old magnifier, and this is like super weird. This is again not what I would have expected, because our local position, our world position is still 0, 1, 0, which is because no, this is okay. This is okay. I moved the cube, but I moved the cube in play mode. So it got reverted when I exited play mode. So let me exit play mode actually. So yeah, since the cube is at 0, 0, 0, of course, world and local are the same. So let me place the cube at, I don't know, 1 on the x-axis and 2 at the y-axis or something like that, to keep it interesting. So let's now run it. And now this should look interesting. Yes, look at this. Our world position is at 1, 3, and 0, while our local position relative to the cube is at 0, 1, 0. So there you already have how you can get whatever you want to have, whatever you need in code. Because if we just get the position like I wanted to do and like I'm going to do, we are actually getting the world position. So transform.position is actually the position in the absolute position in the scene. And if you do want the local position that's relative to whatever parent object there is, you just use the local position. Okay, so let's put this away. I don't think we need this anymore. Let's clear this up as well. Let's get, oops, whatever I did there was not what I wanted to do. Yeah, totally not in control of my keyboard shortcuts. Sorry for that. Okay, we wanted to create a variable which is a vector 3, because again, if we have the position here, we can see this is a vector 3 because it has x, y, and z. So let's create a variable called current position, and I'm taking the liberty of abbreviating position a bit. And if we have a current position, we also will have a new position. And I'm going to be spoiling a bit because there's another thing we're going to be having, which is our actual movement. Let's call this movement vector. And we're just going to be, because we're lazy, we're just going to be initializing this. And we're going to be moving 1 on the x-axis and nothing on the other 2. So we have a movement vector that says, okay, we want to move 1 on the x-axis and nothing on the other ones. So what we're going to be doing is, with this position, we're going to be saving this into our current position variable. And, well, this one's quite easy because the new position is the sum of those two. Because to move our object, we just add our movement vector, which is how we want to move, or yeah, how we want to move, we just add this to our current position. So it's basically current position plus our movement vector. And this is a very nice thing because you can just add vectors together like this, because the vector itself overrides this mathematical plus thing there. So this actually works. This gives us a proper vector back, which actually is the sum of the two x's, the two y's, and the two z's. This is pretty neat. Another way, what we could have done is we could have said new x equals current x plus movement x, and doing this for y and z as well. We could have done this. Y and z, and also this is new position, not just new, and then it works. See, as soon as you do it right, it works. Is this Visual Studio Code? The IDE, no. The IDE I'm using is JetBrains Rider. Do I have an about somewhere here? Yeah, come on, there's an about somewhere. The IDE I'm using is JetBrains Rider because I'm working with JetBrains IDEs for I don't know how long. I'm using JetBrains IDE in general for quite some time now. So I am very, very happy that they do have a variation of their IDEs, that they do have Rider, which is optimized is the wrong word, but it knows for one, it's for C#, so it does know all the stuff you need with C#, but it also knows about the special things about Unity. JetBrains has a lot of great IDEs, yeah, for almost every language. We just recently only found one thing where there's not a JetBrains IDE for, and this is the proprietary programming thing that Houdini uses. Not the magician Houdini, the 3D tool Houdini. See, Mooney Machine also says you're familiar with Rider, best IDE. Yeah, I'm a sign that. Absolutely, I love it. As I said, I'm using JetBrains IDEs for other languages for, I don't know, many years. So I was very happy to see they have something for Unity as well, and quite new. They also yeah, they might not have an IDE for brainfuck, because, well, the name's the deal. If you do that with an IDE, well, where's the fun? What was I about to say? Lost my thread there. Where were we? We're at IDEs. Oh yeah, they also have a special IDE for Unreal now. They have a version of Rider that is tailored for Unreal. So it does C++, but also knows all the special things that the engine does, just like this one. So this is whitespace could also be difficult to find the IDE. Yeah. Sorry for the distraction. Oh no, I mean, this is perfectly fine. Distractions are perfectly fine. I mean, this is a live stream, so it's basically distraction zone. Perfectly fine. This is nothing. I've been wandered off the road of stuff I wanted to originally talk about way worse than this. So this is perfectly fine. So yeah, we could have done this, and maybe sometimes we would have needed to, but since the Vector 3 implementation of Unity is a quite nice one, and they override the addition. Basically, they override the addition with an own method that's embedded in the Vector 3 that does basically this, and then returns this new vector. So this is one way of doing it. If you want to, you can do this. This is perfectly fine of doing it this way. But I mean, come on, we are IT people, especially developers. We're lazy. We're inherently lazy. At least I am. So I'm perfectly fine with just doing it like this. So now we have a new position that is the sum of our current position plus our movement vector. And I can already hear some of you shout. I can already hear some of you mumble time delta or delta time. And yes, we're coming to this in a minute. We'll be talking about delta time. We'll be talking about why this alone is a bad idea. Because this gives us Fallout 76. Unfortunately, time-based movement. Yes, absolutely. We'll be talking about this in a minute. This is just to demonstrate that this actually works, and then we're actually going to be doing it properly. I can hear you shout, and you're absolutely right. You're absolutely right. This is not good. This is Fallout 76 or Fallout 2. Unfortunately, I can't demonstrate this because I don't have a really usable way to get my frame rate down, unless I don't know, put something really stressful in the background on my graphics card. So I can't actually demonstrate this. So you just have to believe me. And I think there's a good reason why you can believe me. Because if I tell you something that's not right, there's enough people in the chat that will immediately shout, "Stop, this is bull's poo-poo that he's telling you." So the people in the chat not shouting "stop" and calling me a liar should be a good reason why you could consider trusting me on what I say. Because I trust in the people in the chat to shout at me as soon as I say something that's not right. Can I clip FPS in Unity? Oh wait, there's one thing. Oh wait, maybe this will work. I'm not sure if this will work, but we can actually set the frame rate. I just forgot how it's called. So let me just Google this quickly. Unity set frame rate. But there's actually application target frame rate. Exactly, that's it. What we can do is, in our start method, we can say application target frame rate 60. And we're going to be reducing this to like 10. And maybe this will work. Maybe this will work. Frame rate X, or you can enable VSync in the player settings. Yeah, however, the FPS can drop below that level. Yep, went back and played Fallout 2. Mechanic of traveling across the desert was broken because it was effectively instant. Yeah. Let's try if this works, because you can tell Unity what frame rate you want to run at. And yeah, VSync is a good idea as well. I think I already clone? No, I didn't. Set VSync, but this doesn't always work for some. So this is quality settings VSync count, and I think setting it to 1. The number of VSyncs that should pass between each frame. Use don't sync 0 to not wait. Okay, value must be 0 to 4. Great. Quality settings VSync count. We do this. We totally do this. Quality settings VSync count. We set it. Let's set it to 1. Maybe it works. Yeah, let's try this. This is always nice to have. So maybe we actually can demonstrate this. Different platforms behave differently, and the editor has its own. Yeah, the editor sometimes behaves completely different than anything else. But that's a whole lot of a different story. It's hard to know what every computer in the world it will do, but Unity is still great across platform. That it is, especially mobile. I personally prefer Unreal, working with Unreal. But something that Unity actually does really, really well is mobile, and something that Unreal doesn't do at all, but Unity also does quite well as web export. So you can just run your game in a web browser. The other way to overload your GPU would be to fire up Firmark in the background. Yeah, that would be a pretty mean way to give the GPU enough to do so the frame rate would drop. But hopefully this will work. So, because all we have to do now, we already have our new position and we know where the position of the object is actually stored. So all we now have to do is to say, yeah, you know what? The transform position is our new position. Bam. And this should do it. This should be it. And you can already see that Rider's nagging me a lot. And this is one of the reasons why I do like Rider so much. Because it tells you every single bit that might be not... now I lost the word. Best practice. There it is again. It tells us here, like, yeah, you know, you could join the declaration and the assignment, which I personally actually don't like. But what we could do is we could just take this bit there and move it up there. And then we could just take this part and move it up there, but then it has to be below there because movement vector doesn't exist. So we also could do it this way. I kind of don't like it this way because I find this harder to read. So I actually like to do it this way. Also, these are green wiggly lines, which means, yeah, this is a suggestion, but if you really don't want to, you don't have to. It's fine, but the yellow ones are actually the yellow ones we actually should take care of because it tells us repeated property access of buildcom is inefficient. We actually should do something about this. So we will create a new variable which is of type transform. I think just call this our transform, and we can actually put this there, and it doesn't work because of, yeah, it's a vector 3. Sorry, no, wait, stop, it's not position. I wanted to have the transform. No, it's right, I wanted to have the transform. Wouldn't it be best to do it in a single line with position? Yeah, you're right, we could even right, this is even a shorthand we could use. We could use the plus equals, which actually is a good suggestion because I like doing it like this. So our new position, why doesn't this work now? Because we haven't set current position, which is basically our transform dot position, and then we can also here say our transform. And see, all the complaints from the IDE are gone. And yes, we can actually say, no, wait, we can't. I mean, what we could do is we could do current position plus equals movement vector. But then we got our new position in the current position variable, which is, well, it's not right because current position is then the new position. We could rename this. We could just rename this to position. I think this is personal choice. We could just call this position. We could just say, hey, why don't you do what I want? We could just create a position variable and say, yeah, you know what? This is our position, and then we could do just position plus equals movement vector. It's perfectly fine. You can do this. But since we have it split up into current position and new position, let's keep it like this. But you can, could do that. Using the transform position. Oh, you mean immediately using on the transform position. Yeah, that should actually, yeah. All right, now I see. Okay, yeah, perfectly valid. Yeah. But for now, so we know really what we do. Let's keep this with separate values, separate variables. So we know we have our current position, we have our new position. But absolutely, now I know what you mean. We could just say we could, in theory, we could scrap all of that. This is what it means. We could scrap all this, and we could just say transform position plus equals new vector 3 1 0 0, and you have all of this condensed into one single line. Perfectly valid. But if this is a bit more verbose, so we actually know what we're doing. But yeah, in an actual project, I think you would find more of these rather than this. Yeah. But for now, let's stay verbose. So we absolutely have no question marks in our head like what we're doing here. So we're declaring all our variables, and we set our current position to our current position. We calculate the new position, and then we set the new position into the transform. Now you see this is grayed out. This is grayed out because we're not calling it yet, and we want to move every frame. So in our update method, let's just call our move. Yeah, that's cool. So let me just catch up with chat. So cache your reference to transform. Exactly. This is exactly what we did here. This is as I said, this is one of the things I love about working with Rider, because Rider already told me, dude, this is not cool. This might become expensive. Remember this somewhere where you can just reuse it. Exactly what you just said there. Cache the reference to transform. Exactly what we did. And Visual Studio does not do that. Good Rider. Yeah, exactly. So we're totally on the same page there. Because Rider does not only know C#, Rider knows about Unity, and Rider knows about the specifics of Unity, and this is what it makes such a great tool. So for us, optimization, looking at the kind of thing, it's always seems the compiler will figure it out for you. Yeah, there's compilers who complain a lot. Well, mostly they're right. So, alrighty. Okay, so if we save this and go back to Unity and wait till it's done compiling, we move the cube back to 0, 0 for a nice centered starting place, and we remove the component from the sphere again, because for now I want to have it on the cube. And it's down there. Well, I want it up there. Can I move it up there? Oh yeah. So we have easy access to it, and we can easily, because there's a few other things, because right now these values are hard coded, which is always not cool. It'd be way more cooler if our movement vector could be settable from the inspector. So you, the coder, you implement the moving, but the game designer can actually change how it moves. That's way more cool, and this we're definitely gonna be doing this today. I don't think we're gonna be doing everything I actually planned for today, because another thing I wanted to talk about with you guys is to make this based on keyboard input, on player input. But I think we're gonna be doing this next week. So, but we're definitely going to be doing this. How do I get these values to be settable from the inspector? That's definitely something we're going to be talking about today. So let's run this and let's see what happens. what should happen is, wow, this is quick. And it moves really, really fast. It moves really, really fast. Yeah, I mean, if you see, this cube is 1 unit in size, and we're removing 1 unit per frame. So let's see, these are supposed to be floats, so I should have done it like this anyways. Because those are actual float values. Those are not integers. So let's put this to 0.1. So maybe we can actually see it move. Is it bound to the frame rate? Right now it's bound to the frame rate, yes. And we're going to be talking about this. I'll try to demonstrate. I will try if changing the frame rate to something lower, if that actually works, if this has any effect, to demonstrate why this line is not complete yet, why there's something missing. And exactly what you mean. It's missing exactly what your question aims at, yes. So if you run this now, given I didn't forget to save, yeah, it's moving a bit slower. No, so this is cool. You can it moved out of the camera view quite fast, but you can still see it moving there. So let's restart this, and there it is. There it moves away with 60 frames per second, 0.1 units per frame. And now let's see if it works if I set the frame rate to, I don't know, 10. Let's see if that works. I don't think I can set it higher than 60 because my frame rate here is actually 60 frames. So it wants to go home now. Yeah, who doesn't? Well, I am home, so that's fine. Oh yeah, look at that. We are now running at 10 frames per second. And do you see the difference? It's moving way more slower. Like, do we have a stopwatch somewhere? Let's see how long it takes to move out of the view of our game camera down there. It takes quite a time. I mean, it starts moving, and it moves, and it moves, and it moves. It's still moving. We're still going to be seeing it. And we're still seeing it, still moving, and now it's out of the frame of our game camera. You can see how slow this is moving because right now we're running at 10 frames per second. So now let's get back to 60 frames per second and try to compare it with what happens then. So let me start this, and this moves so quickly out of the camera view. Well, okay, there's some time where we can see it, but I think you can already see this is moving way quicker now. This is moving way quicker now because, and this is a problem. This really is a problem. Our movement speed is bound to our frame rate because right now this is called every frame, once per frame. So what we're doing is we're moving 0.1 units, which every frame the game renders. Which means when we're running at 10 frames per second, we are only moving 10 times 0.1 units. And if you're running at 60 frames per second, we're moving at 60 times 0.1 units per second. And that's something we don't want. We don't want the speed of our game to be bound to the frame rate because this means that on really beefed up gaming computers, newest Ryzen, GTX 3090, and pushed to the limit, our game will be insanely quick, maybe unplayable, like the Fallout 2 example from before in the chat. Our game will be unplayable because it's too fast. And if you have an older computer and it runs at, I don't know, lower frame rate, our game will also be unplayable because it is so slow. So, what do? there's a very nice thing that the engine offers us. And for this, I'm going to be setting this back to 1 because I know that this is a good value then. Our movement vector just tells us how fast, in what direction do we want to move. And currently this is per frame. So it would be totally cool if we could do this like per second. If the value I give here is I want to move this distance every second, not every frame. Sounds cool. Sounds like, oh boy, that's like super complicated. And no, it's not. Because all we have to do is to multiply our movement vector by something the engine gives us, which is time, because it's time related. And time has a property delta time. And delta time is the time in seconds since the last frame. Binding physics to the frame rate. I saw 9090. So why is it still used sometimes? I have no idea. I have no idea why there is still developers who I mean, it's so easy. I mean, you just multiply it with delta time. And then you're completely frame rate independent. This simple multiplication that, by the way, because, well, yeah, this might actually work because of mathematical rules like this one comes before this one. But let's be super sure. Let's be super safe. Let's put brackets around this because we first need to multiply our movement vector with the delta time. And the result of this is then added to our current position. And delta time is the time since the last frame in seconds. So on a 60 FPS game, if your game runs with 60 frames per second, this should be around 13 milliseconds, which is 0.013 seconds, I think. So this should be 0.01. Because this is the time since the last frame. Which means that if your game runs at 60 frames per second, after 60 frames, if you add all of these up, if you create a variable and you add this up, after 60 frames, you should have roughly a solid 1 in your variable. Because if this is the time since the last frame in seconds, after 60 frames, you should have a second if you have 60 frames per second. I hope this makes sense. If it doesn't, please feel free. Every question is welcome. There's only one. I say this all the time. There is only one stupid question. Only one. One single stupid question. And that is the question that's not gonna been asked. Yeah. I'm gonna be trying on my speech processing. The only stupid question is the one not being asked. So ask away if this doesn't make sense. I try to do my best. So this completely decouples us from the frame rate. Because if the frame rate becomes slower, the time between each frame, i.e. the delta time, becomes larger. So we move more. And if the frame rate becomes more, if we're running at 240 frames for something, the time between each frame becomes smaller, which means due to this multiplication, we're moving just tiny little steps. So after a second, we've moved the very same amount of units, space, whatever. So let's try this. Let's just try this. Let's run this at 60 frames per second. And it's moving quite slow now. because I set it to, it's basically moving one size of this cube per second, which is quite slow, but so we have a nice, movement to look at. But to see, I think we're gonna be putting this, let's put it to 2. So if there is a difference in speed, we can better see it, because if it's already slow, if it's getting even slower, this is hard to see. So let me try timing this, because I really want to show you that we are now completely independent from the frame rate. Let me get a stopwatch, which is there. The way it moves smoother. Then I run on 10 frame. Yeah, it's just moving exactly. The difference now is with lower frame rates, it's not moving as smooth. It will look quite stuttery and unsmooth. And the higher the frame rate, the smoother the movement will be. But the distance it moves, the speed it moves with, in total will stay the same. Most important, it moves the same on all machines. Exactly. So let's see. I got my stopwatch here at 0, and let me see, to make this in a way so you know I'm not cheating. I start this, and once it starts moving, I'm gonna try to hit the start thingy there, and eventually it's out of sight now, which is roughly 6 seconds. 5.8, giving my, I don't know, my brain lag to hit the buttons. Let's round this up to about 6 seconds, because now we're gonna be down to 10 frames, or let's even set this to 5 frames per second. So this is super slow. So before, or if I say, oh, you know what? Let's set this to 6 frames per second, because before we've accounted for the delta time, we'd now move 10 times as slow as before. So timing wise, this should give us quite some difference. So let's start this and see that I can hit the button blindly. And okay, I didn't hit the button there. Okay, you just have to believe me. I'm not cheating with this. So it starts moving, and it moves, and it moves. It's still moving, and now it's out of sight. 6 seconds. Look, I even hit the 6 perfectly there. So the speed it moves is exactly the same. And this is the important thing. And it's so easy. All you have to do is instead of just adding your movement speed, just multiply it with the delta time, which automatically renders this to be units per second. This simple thing takes care of all we need. So these values are now in this distance per second. And it doesn't matter if you have a high-end gaming PC with super high frame rate, or a super low potato with 6 frames per second. The speed of your game is the same on all of them. It's just like that this doesn't look as nice. It's stuttery, and you know, I mean, this is what you get with low frame rates. And with higher frame rates, it just looks smoother. But yeah, I don't know. I've said this too many times, but you know what I mean. The speed is the same, so your game stays the same, and this is that. Haven't you echoed somewhere the positioner should be able to echo the speed as well? We can do this. We can. What we can do is we can put a log in here. That, I mean, we're just moving on the x-axis. So let's say moving distance is, and then we put our we put this in there, and then we want the x value of that, and then we're gonna be putting another thing in here that tells us the delta time is, and we're just gonna be outputting us the time delta time. So now we can even see this. We saw that this is a measure of the time. Exactly. So the moving distance, yeah, which is basically the speed. I'm now just outputting the distance and the delta time, which is basically tells us the same. So with 60 frames per second, the delta time is about 16 milliseconds. It's 0.016, and our moving distance is about 0.03 units. So with lower frame rate, these should all be greater, which is, I think, the final proof that this is the way to go. Here we go. Yeah, and I mean, since it's 10 times as slow, we just changed 60 frames to 6 frames instead of 0.016 delta time. We now have 0.16, and our moving distance before also was 0.03, and now it's 0.3. So yeah. I think this should absolutely make clear that that's the way to go, and not doing this is totally not the way to go. So before let me catch up with the chat before we get to the final thing we're going to be talking about today. You can even write unit tests that run examples like this at various FPS. Yeah, and you should. And don't let the game compile unless it always ends up at the same target at the same time. Yes. Unit tests are a whole other yeah, unit tests are a completely different topic. But yeah, absolutely. That's a good idea. Is it possible to do unit tests in Unity? I have to admit, I haven't tried yet. I haven't tried that. Unity has even a unit testing framework that allows you to actually run the game and test scenes. That sounds good. I haven't done unit tests in Unity yet myself, because unit tests. I yet have to meet a developer who says, "Yeah, I love unit tests." To find a developer who doesn't say loves unit tests is not the wrong thing. I do love them. They are totally cool. They are super useful. They are absolutely the thing you need to do. And they saved my ass, actually. I had a few situations where a good unit test actually saved me a lot of work. So yes, totally cool. But yeah, I've yet to find a developer who says, yeah, I write unit tests. I like writing unit tests. I write them all the time. Because exactly, don't have time for that. Usually you need to get your stuff done. And that's enough pressure already. And then because a good unit test might take as much time writing as writing the method you're testing in the first place. So if you spend 2 days, well, not exactly. If you spend 2 days on writing a method, you don't need 2 days to write your unit test. But it takes time. It takes time, and most of us prefer using that time to do something else actually productive that like adds a new feature or something. And most of the time, it's not even because we like it; it's because we have to. But yeah, that's a whole other beast, like you just put it. That's a whole other beast to tackle. I don't know. Maybe we make a few special episodes about unit tests. Because I said I haven't done unit testing in Unity as well. And for me personally, unit testing in Unreal would be a bit more interesting because I work more with Unreal. Yeah, but that is quite something. So the last thing we're going to be talking about, because now it's moving, right? We set this back to 60 FPS, and it's quite nicely moving. So we, as the developers, the coding guys, we now made this thing move. We implemented the functionality, the feature that this thing can move. Now our game designer comes to us and says, you know what? That's pretty cool what you've done there, but the speed is wrong. I need this to be at a different speed. And he has to tell us this, because then we have to dive into our code and change this value. And then we compile this, we commit this, he pulls this, he tries it out, and he's, now it's too fast. Before it was too slow, now it's too fast. And again, we have to dive into our code, you get the picture. So there's a very convenient way to avoid this. So while we implement the functionality, our artists, game designers, or whoever can change the actual values. And this is best practice. Hard-coded values like this. In 90% of the cases, hard-coded values like this are a bad idea, not the way to go. Usually values like this should not be hard-coded. So what we could do is, and you know what, let me clean this up a bit by removing these comments, because we already know what they're doing. We could create a property, or the proper name in C# would be a field, because the property would be the getters and setters, but let's not get into that. I still call these things properties, so please bear with me. I know in C# they are actually called fields, but since C# is not the only language I work with, and for consistency, bear with me, let's call these properties. And let's call the actual C# properties, let's just call them getters and setters, and then we're all on the same page. So let's create a property, and of course we always create private or at least protected properties, never publics. We've talked about this in excruciating detail last year when we did Unreal. When we did Unreal, I did one evening on I think we even did 2 evenings on best practices, and I talked in excruciating detail why we do not make these things public. So go back and watch that. And if you want, we can talk about this again. I love talking about these things. So if you say, oh, I don't want to watch the old stream, I want you to talk about this live right now again, yeah, we can do this. I love talking about these things. And thanks a lot. Very glad to hear you're enjoying the stream, and maybe even finding this helpful. Thank you. That's very nice to hear or read in that case. Hope to catch me next stream. Yeah, we're currently doing these tutorials every Thursday on 4 p.m. And sometimes I do coding streams on my own channel. Right now I'm actually playing Subnautica Below Zero, but yeah, once I'm done with that, I'll do more coding there as well. So yeah, cool. Yeah, we make private, and what do? We want our movement vector here. Oh, you already followed my personal one too. Thanks a lot. Very much appreciated. Looking forward to seeing you. So we could basically, yeah, we could just, yeah, you know what? Now let's try. We make a vector 3. And we call this, let's just call this movement. So this is our movement. And you see my IDE already complains with a yellow squiggly line, because if this would just be a private property, it's supposed to have an underscore in front of it and start with an underscore. I did not put the underscore yet because I already know I want to do something else that will also get rid of this yellow squiggly line. Because if I compile this now, there is still no way to actually set this from the inspector. See, it's not here because it's private. It's ours. Nobody else has to care about this. But for Unity, there's a special decorator. You can say, okay, you know what? This is a serialized field. And this actually tells Unity that this is something it should sneak into and work with, let us work with. So if I just compile this, we will see that in the properties of our component, we suddenly, here's our movement component, and we suddenly have a movement value here that has X, Y, and Z that we can set. Oh, this is cool. X, Y, and Z that we can set. And now all together. What was my channel? Oh, yeah, Lakeside. Thanks a lot. Thanks a lot. Yeah, it's the same as, I think you can't read it because in this view it's quite small. This is my, well, there's my Twitter handle down there. The Twitch channel is the very same thing. But I think in this view it's quite small because in this view the focus should be on all the stuff up there and not on me. So an even better view would be getting rid of the camera altogether. But nah, this would be too impersonal. We don't do that. So yeah, if you put this serialized field in front of a private property or field in your class, Unity will start seeing this. And even though this is private and can't really be accessed by normal means, of course there's ways, hashtag reflection, which is actually exactly what Unity is using here. So if we put this serialized field in front of our private property, Unity will start seeing it, and Unity will put this in the inspector so we can set this. So now let's just use it, and because we're lazy, instead of actually setting a new vector, blah 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 blah, we will just set the movement vector to our movement from above. Of course, what we could do is we could just get rid of this movement vector variable altogether and just replace every occurrence of this with movement. But just to show this is the simple drop-in replacement, we really don't need to change anything in our code. Instead of just creating a hard-coded vector 3, we just use whatever's up in there. Yeah, no, this doesn't have to be null. Okay, I was just thinking at a warning that Unity might give, but I don't think in this situation it would give us the warning. But we're going to see in a second when it's done compile. Oh, it actually does. Always its default value. Okay. In a matter of clean code, I am someone who treats every error, every message as fatal as a red error. This is just a warning. The compiler tells us, yeah, I'm warning you about something. It might work, but this is not perfect. I personally like to get rid of all the warnings as well. For me, warnings or notices or anything else are as important as a fatal red error. So it tells us that this field up here doesn't have a default value, and it will use some type dependent defaults, which is fine, but it's not cool. So we're gonna be initializing this with an explicit default value, which is just a new empty vector 3. This should work. Yes, it's completely redundant. This is why my IDE makes this gray, because it's not necessary. The result is the same, but it should remove this warning, which it does, because now this doesn't have a default value because there's one put in because it doesn't have one. Now it has a default value because we're explicitly setting one, which in case of the serialized field, you should always do. If this would not be a serialized field and we would not be put anything, we would have different problems. It would complain down here that the variable is not initialized at all. So we would maybe, I usually don't like to put these default values up in. Usually I put them in the start or in the awake function and set the defaults if I need them. But this is personal preference. Both is fine. In this case, it's just really needed like this because it needs to be there from the get-go. So yeah, the compiler, it complained a bit. It gave us a warning, and I don't like warnings. So I like to take care and get rid of these warnings as well. Because I've had it enough times where even a notice, it wasn't even a warning, it was just a notice, caused quite some problems down the line. So I don't care if it's a notice, a warning, or a fatal error. I treat every of these messages like a fatal error and try to get rid of them, which you should do as well. Saves you some headaches down the line. So yeah, now we got our movement component. We can actually set the movement right here. So let's set this to 2 on the x-axis again. And if I run this now, there should be no difference. Yeah, because the value is pretty much the same than before. But while it's running, I mean, I can change this while it's running. I can set this to -2. And now it's moving back. And while it's moving back, I can set y to 2. And now it's moving diagonal. And I want to have it back. So set this to -2 and set this to +2 and set this to 2 or maybe -2. And it's moving towards us. And now it's not. And let's change this. Or you can really have fun. You can really play around even while it's running. And now it's completely gone. I've no idea where it's now, so let's reset this. So with this very, very simple thing, instead of just using a hard-coded value here, you created a private property, and then you told Unity that it should care about this private property by just putting this serialized field in square brackets on top of it or in front of it. I think the actual convention is to write it like this, because if I tell my IDE to clean up my code, if I tell my IDE to reform my code based on the official best practice coding style, because I didn't change the defaults. You can change this to whatever I want, to whatever you want, how it formats it. But by default, after a fresh install, it defaults to the official best practices. It actually puts the serialized field actually directly in front of it and not on top of it. So, well, since this is the official suggested best practice style, I'll be using this. I like this a bit more. Yeah, but I also like complying with the best practice standards, and this is this. So you just prefix the serialized field, and then you get your value. Where is it? There, and you can edit. You can do this with whatever you want. And Dominic, greetings go out to you. You can say, I don't know, okay, this is not what I wanted. You can say private. Let's just take in for it's just an example. This is some value. Of course, initialize this so it doesn't complain later down the road. And this is some other value and let's set this to a default of 42. I don't know. And let's have a string. String, this is some super important important thing, and by default this, I don't know, is empty. And then you just prefix these all with the serialized field, because these are some values that somewhere down in your code you're going to be using them, and they're super important, and you want your level designer, your artist, whoever you want them to be easily able to change these values. You just prefix them with serialized field. And if we go back into Unity, once it's done compiling, you can see, let me fetch the old magnifier again. There they are. There's our movement, there's some values, some other values, some super important thing. And they are also neatly formatted. I mean, look at how they are written with spaces and everything. Like, these are actual labels. They look like super nice. While in our code, we just have our property names, because Unity makes this a bit more human readable. It starts everything with an uppercase character and then puts spaces in between, which is basically all it does. But it makes things a bit more readable. So you can neatly look at this and, oh yeah, this is some value, super important, and we need to type something in here. And then you can just use, and I think we just went down. Are we still live? No, we're not. Or are we? Oh, we might be back. Okay. This might have just been a problem on my preview on the dashboard, but it's a bit. Bitrate is a bit low. I'm not sure if you guys can still see or hear me. Maybe my chat's even broken. Let me try opening that, refreshing that. Welcome to the chat room. Okay, we should still be there, but for some reason the bitrate is crashing hard. I have no idea why, but we're done anyways. This is the last thing I wanted. Stream was stuttering, but now it's okay. Good. So if it only was stuttering, you might have. Let me check my bitrate again. Maybe that. Nah. I don't know. I have some problem with the bitrate. It's crashing down. It's going down to something it's not supposed to be. But we're done anyways. So before this completely goes away, why I don't know why ever I all of a sudden have got internet problems. And it's complaining. It's complaining about the fields not having default, but I put default values in there. Well, anyways, I'm done anyways. So as long as I still have some internet to talk to you, this is the last thing I wanted to talk to you about. This is how you make your values accessible in the inspector. So if someone clicks on the object and your component is on there, here's your values. You can easily edit. And you can then just directly use whatever has been put in here, like the speed, like let's set this all to 2 maybe, and then hit start. And you see it moves into a completely different direction. And you can even change these at runtime. We can make them all negative, so it should come back eventually. Yeah, there it is. See? It's like a hot air balloon. It's coming back. It's settling down. So yeah, this is it for today. This was our first C# script where we made things move, and we took a look at how we access things at all, how we make things do something like move, and how we avoid hard-coded values by making them accessible up there in the inspector. Okay, this is it for today. Before my internet completely collapses, thanks a lot for being here with me today. And I think, yeah, next week, Thursday, 4 p.m. CET, we'll be able to see us again. Thanks for being here, and glad you enjoyed it. And yeah, that's it. I would say over and out. See you around. Have a wonderful weekend. Don't forget, we are almost in the weekend. So have a nice one. See you around. Bye and take care.